The next thing on your schedule is a homework assignment that's due Sunday. And today we're going to be talking about how to combine the idea of annual worth analysis and incremental analysis. And to do that, we're going to work on in-class exercise 23. Did everybody get a copy of in-class exercise 23? You know, we're officially halfway through the semester now. Actually, more than that, because I think we've got 43 class meetings through the semester, and we're at 23. So we're on the downhill slope now. I wanted to clarify a couple of ideas. I got some questions about this figure. You remember that in one of your previous homework assignments, you set up a table that showed the unrecovered investment balance and how it decreases over time. The R and the E, those variables on this figure, stand for revenue and expense. And what it meant was that every year, your business hopefully is getting more revenue than it's getting expenses. And so the difference between the two is what brings your unrecovered investment balance down. In other words, you're making a profit every year, and the profit that you're making is what justifies that amount you spent at the beginning of the cash flow diagram. The other thing is that if there's a salvage value, then we're trying to find out, how long until your unrecovered investment balance is zero. That includes the salvage value of the item. So in this exercise, what you were doing is you were finding out what is the interest rate that causes this unrecovered investment balance to get down to zero over time. The other thing I wanted to point out is there's a lot of I's that are being used for variables in the textbook. I hope that you're doing reading. In addition to listening to lectures, it's really important for you to be reading the text. And as I said at the beginning of the semester, if you're not reading the book, you really don't have any justification for expecting an A grade in the course. Reading the text is just, it's the most basic way that you can study. And if you're not doing it, then you don't have any right to expect superior results. So in the text, they're using I a lot of different ways, and I wanted to clarify some of the different ways that I is being used. First of all, the first thing that we were speaking about at the beginning of the semester is the idea of interest, and it's an amount. So capital I is meaning that amount that is paid for the privilege of borrowing money. Lowercase I is when we express that as a percentage, a fraction of the original amount. And interest rate is when it is broken up into a time period basis. And most commonly in this course, what we've been doing is we've been expressing the interest rate per year. So we've been using annual time rates. Sometimes you'll see I star. Now the star often is denoted to mean an unknown interest rate that we're trying to solve for. And so in the text, it's usually saying I star if we're trying to find internal rate of return, for example. Or in the example of that unrecovered investment balance, if we don't know what the interest rate that causes the unrecovered investment balance to go to zero, they'd usually label the unknown as an I star. What it means is it's the compound interest rate on a per period basis expressed as a percentage, and this rate of return makes it so that the outflows and the inflows are equal. And that's the definition of internal rate of return, is assuming that the investment can be reinvested into the original project. It's the interest rate that makes the present worth of the inflows and the outflows in equilibrium. All right, here's where it gets a little more complicated. I prime is what they use to refer to the external rate of return. And you've just done an external rate of return problem, so we don't need to talk a lot about that. But I prime, when they're using variables rather than the full name of it, I think the full name of it maybe is the way to go because it's less ambiguous, but they're using I prime for that. Remember, epsilon is what I've called the external reinvestment rate. In the text, it sometimes calls that I sub I. I thought we had enough I variables already, so I stuck with epsilon, which is what the variable that's assigned in the previous text that I used is for external reinvestment rate. And that's that secondary account that your revenues are invested in if you can't put it back into the project. And then delta I is the incremental rate of return. And we've been doing incremental rate of return, and we're going to continue with it today. So those are the variables that I wanted to sort of clarify. And like how I started, if you want additional clarification on that, I'd encourage you to take a look through the textbook. All right, annual worth analysis. Remember, we did annual worth analysis just because sometimes it's important to know how the project is doing on an annual basis. An example of that might be for tax purposes. If the government charges an annual income tax on your business, you have to know the net difference between the inflows and the outflows expressed on an annual basis. If you're trying to figure out on an annual basis how much you can take out of a business, to pay yourself to take out your profits, then you would like to know the annual worth on an annual basis. Those are just two examples of why sometimes you'd rather know things on the annual basis instead of taking everything to the present or everything to the future. What we're going to do today is take a look at a method that allows you to calculate the incremental rate of return on two projects by finding the annual value. So remember, the incremental looks at the difference in first cost. In each of the opportunities we've looked at, the pattern has been you pay some at the beginning and then you get revenues over time. In today's example, actually what it is you pay something in the beginning and then you have annual payments to begin, annual payments after that to continue using the item, but the one that's more expensive would cost less over time. And so basically what you're purchasing is an annual savings. So there's a very detailed list of what you should do and a pattern that I've given you on the spreadsheet. I'd like you to get started with that. Since we're in the computer lab, you can easily fire up Excel, and we're going to do another one of those. The instructions are on the page A through G, and what you're looking at is two different alternatives. And I think that the instructions I've given you on the page are going to help you to see the annual worth analysis method. And as we get closer to time to finish for the class, I'll bring up the solution on the screen. This is what your Excel spreadsheet should look like to begin. It should just be these empty spaces and all the same data that I gave you on the in-class exercise paper. Once you have your spreadsheet like this, then you can go through the instructions. Actually, instruction A is making your spreadsheet look like this. So if you just read the directions, I hope it'll be clear from the in-class exercise what you're supposed to do. All right, so here's the template that we start with, and we don't know exactly what the incremental rate of return is to begin with, so I'm just going to guess maybe 1%, just to have that there. Okay, we want to find the annual equivalent, so it's going to be equal PMT. The PMT tells you, basically, it stands for payment, and it's saying what would the payment be each year if you wanted to spread out the initial cost over a certain number of years at a certain interest rate. Okay, so here's the interest rate that we're going to use. You can see it's giving me the prompt. The first thing I need to tell it is the rate. So I'm going to click in this field and press F4 to anchor it. Comma, NPER is asking how many years. So it'll be 10 years for option A. Now, present value. It's going to change the sign if I don't put the negative in there myself. So I'll just click negative, and this initial cost is in the present. So then that's all I need to do, and it tells me that at 1% interest rate, the annual equivalent of 8,000 is 844.66. And I can copy that function just by doing Control-C and over here Control-V, and I don't have to type it in again. It gives me the amount automatically. I'll just double check to make sure that it's using the right areas for that, the right fields. Yes, it's using, this is the amount, this is the years, and it's looking in the correct place for I. Okay, so I need to do, the annual costs are already in an annual basis, but now the salvage is going to be a little different, equals PMT again. The rate will be the same rate. The N will be whatever the N is in that column. But now the salvage value isn't in the present. The salvage value is in the future. So I need to skip over the PV field by putting in an extra comma. And now it knows that whatever I give it is some future value that I want to spread out over the present. So I do FV, negative of that, and I close. So salvage value is 0. The annual equivalent will be 0. So I'm going to paste again, which just pastes the formula. So this seems reasonable that if it's 2,000 in the future, over 5 years, that works out to 392 each year. Now over here, I'm going to do the sum of, I've labeled it X, Y, and Z. So the sum of X, Y, and Z. Okay, let me make that a bit wider. All right, so that's the annual amount, and I'll copy, Control-C, paste, Control-V. And the reason why I have this difference down here, the difference between the two, is I need to use goal-seek to make it faster. And what I know is I want them to be the same, which means the difference should be 0. So when I go here to Data, What If Analysis, Goal-seek, my goal is I want the difference between the two amounts to be equal to 0 by changing this delta I star, which means that's the incremental rate of return between them. So I let it loose, and it finds it's 12.65%. So what that 12.65% means is option B costs $5,000 more than option A. Option B is more expensive. So your boss wants to know, is it worth spending the extra money? You know, we're not getting revenue from this, but what we are getting, the difference between them is item number B, B isn't a number, item B saves money on an annual basis. Instead of costing $3,500 each year to maintain, it only costs $1,600 each year to maintain. So is it worth spending more now to save money over time? The answer is yes. It does save money over time. Now on the paper it asks you, if your company's MAR is 9%, which is best? Anyone want to guess which item is best if the MAR is 9%? Okay, you say that it's option B if the MAR is 9%. What's your reasoning for that? Yeah? Okay. Right. So he's remembering the criteria is compare the incremental rate of return to the MAR. If we can borrow money at 9%, and let's say that's why our MAR is 9%, if we can borrow money at 9%, but then it returns 12.6%, then we should definitely do it because we're getting more of the return than it costs to borrow the money. So this option B would be justified if our MAR was 9%. So if you didn't quite get finished, you might want to save your spreadsheet file so you can come back to it later. The video will be posted online after today. Write down what you did get. You know, maybe all you got was the annual equivalent of the initial cost. Fill in the blanks that you did complete. And on your way out, please remember to put the in-class exercise on the chair at the end. So remember, when we get together on next week on Sunday, we're going to be back in our normal classroom again. So don't come here. And the homework is going to be due. Homework number 9. I'll see you on Sunday. Have a great weekend.